So, this section is dedicated to talking about accredited monitors. And to begin, it's worth taking a bit of time to explain some monitoring nomenclature or terminology first. And namely, this is what is meant by the word sensor and the word monitor, according to Reset Air. The terms sensor and monitor are often used interchangeably in the industry to refer to both the measuring technology as well as the entire monitoring device. And while that's not incorrect, for reasons of clarity, Reset Air, along with several other organizations and expert groups, follows a convention to help distinguish between the two. In the Reset Air standards, we use the term sensor to mean the measuring technology and the term monitor for the whole device. So for example, in this slide on the left, I'm showing a couple of sensors here. And on the right, I'm showing two different monitors. Now, since the sensors alone would be of little use without some kind of enclosure to house them, there was a real need in the market to design and develop a device that could take these sensors, whether it be a singular sensor or multiple sensors, and successfully employ them into a device. Therefore, what Reset Air defines as a monitor is the whole kit of parts. It's the outer enclosure, the housing or the casing, the fasteners, if it comes with any, to attach it to a wall, the data display, a power source, Wi-Fi, Ethernet connection ports, all those other transmission and retrieval components that are necessary for the gathering of the data from these sensors that it is using. So, as you might deduce, all of this becomes a very complex piece of equipment, and it's really important that we evaluate monitors as a whole and in that proper context. So direct read instruments, or meters, or sometimes called handheld instruments, are yet another category of equipment used in indoor air quality testing. And these are great devices for a walkthrough survey of a space, or when you're detecting or trying to detect a specific pollutant. Because they're mobile, they're ideal for this purpose, and they're very useful for site audits or the commissioning of projects. But the attribute of mobility makes these devices so great also means that they're not typically ideal for reset certification purposes. On the left here, you can see an image of a monitor affixed to a wall in a location to continuously collect data. A handheld device, there's a couple here, isn't really meant to run for hundreds of hours on end, sending data continuously to a platform. And further, because they're not usually fixed in a permanent location, it increases the chance of them being tampered with or inadvertently moved. And for Reset Air certification, monitors have to be deployed according to the standard and remain in those respective locations. So there's a fit for purpose distinction that is important to remember regarding the use of handheld instruments. And then there's the lab testing or spot testing method. And illustrated here are a couple examples of spot testing equipment. Some of you might be familiar with this. And specifically here, I'm showing equipment that's used for the detection of VOCs. And these tests employ a technique where an air sample is collected on site using what's called a sorbent-based or canister-based detection method. And then those samples are brought back to a lab for analysis. And you may have heard of the US EPA's compendium method for determining VOCs, and that document outlines using a method like this. Now, this method is useful in how it can detect environmental chemicals and toxins and pathogens and speciate them. In other words, it can help determine which chemicals and pollutants are present in a space very, very accurately. But delivery of lab results may take days or weeks or months from the time of sampling, and the sample is only representative of the moment in time from when it was taken. So again, there's some limitations to consider with this method as well. So that brings us to continuous monitoring and how Reset approaches air quality. RESET uses continuous monitoring for assessing indoor air quality. And as mentioned, currently most certifications use requirements that call for the aforementioned spot tests or the lab tests, where a sample is collected at a prescribed time under specific conditions at the project site. And RESET is different in that it employs continuous monitoring. So what does that exactly mean? Well, I think it's best explained in this analogy here, where continuous monitoring is akin to a video camera taking ongoing imagery, where a lab test is more akin to a high-definition camera. While the high-definition camera might be able to take an extremely clear, precise picture, it is limited. It is narrow in that it can only be a snapshot of one particular moment in time. On the other hand, the video camera, while perhaps not as high resolution, and maybe you're not able to capture every detail, it does give trending over time, and it's able to show historical data that is incredibly valuable since project spaces are constantly changing and are very much influenced by day-to-day, hour-to-hour, or even minute-by-minute air quality events. So let me just be clear that indoor air quality testing is complex and is full of nuances. So in fact, both continuous monitoring, direct read metering, and spot tests indeed have a place in a complete indoor air quality assessment, but it's important to acknowledge that all of these technologies and techniques have their benefits and limitations respectively. So to illustrate these differences in the approaches of continuous monitoring versus lab testing, this is an example of what a lab test report might look like. And again, it's a snapshot of an air sample, and it gives a detailed speciated report of different pollutants, but it cannot show trends or long-term historical data of a space's indoor air quality. And this is really important because depending on when the sample was taken and from where, the results can be quite different. And to the point, this is an example of what continuous monitoring looks like when the data is visualized. Here you can see a broader picture of indoor air quality over time. You can start to see patterns, you see these peaks and valleys, and this starts to really illustrate a bigger picture that can prove enlightening to building owners and occupants alike. And additionally, it's important to note a couple of other significant benefits that continuous monitoring yields. If you look closely at this plotted graph, what if I had performed my spot test here at this time, or maybe here at this time? What happens then if I perform my spot test at the wrong time versus the right time? Was I lucky or unlucky with respect to my test when I happened to collect my samples? Now, again, we don't discount the validity of chemical speciation or precise lab measurements, but we do need to recognize that indoor air quality, if nothing else, is absolutely dynamic. It changes all the time. It's influenced by myriad factors, by what is happening outdoors, if the HVAC system is working or failing, what materials were installed in the space, what the occupants are doing, and all of these factors are constantly changing. So if your project certification, eligibility, or status hangs on luck, then I think we are in danger of missing the point of indoor air quality assessments. So once we do have indoor air quality, how do we get back to this place where I mentioned this previously in the sections of this training? How do we report back on the parameters that matter to us? Now remember, the point of this is we're trying to attempt to tap into that place of helpful feedback loops, ways that my building can communicate with me. Well, we do it with good data, because we cannot possibly make good decisions without good data. And then that begs the question, what is good data? How do we qualify it? Well, it has to be high quality, and it needs to be understood contextually. So for example, what constitutes good data at home on a residential scale is different than good data at the office, and is different yet of data that might be for a manufacturing plant. So therefore, the context for which the data is collected and then interpreted is critical to the overall understanding and our ability to make proper use of it. So good data allows me to make good decisions. And Reset ends up being at the core of this, collecting data that allows us to keep occupants safe and operate our buildings effectively. So in order to empower Reset Air based on this need for good data, quality data, collected in reliable ways, we needed to develop not just one standard, but a series of standards. So the standards outlined here help us to ensure the following: the proper deployment, the location, and installation of monitors, and that's largely where you, the AP, come in. Standards that define what a qualified monitor is. So as I was just going through, there's a big difference between monitor quality and standards that outline proper collection and reporting of that data. Now, believe me, this is a heavy lift because while most professionals in the indoor air quality and monitoring space agreed that such standards were needed, none existed to the extent for the built environment. So let's go through and discuss all of these one by one, starting with the installation and location component here. Again, we had to talk about how do you have proper location and installation. And this is really to avoid issues that come to pass such as this. Installing a piece of equipment according to Reset standards is really where our APs, are trained and professional and reliable, trusted APs, really have the biggest play. You play a key role because you are responsible for the monitored deployment plan. And previously, when it came to various stakeholders, making recommendations of where to install an air quality monitoring device came with competing interests. We get a scenario like this. The building owner wants to report the information that's coming from a device that's located here, pre-filtered and fresh air. Makes him look good. Service providers, people who maybe make filtration devices and equipment, they want to put a monitor here, which is really not all that useful because it's only detecting air that's coming directly in from the building immediately following a filter. People who make some of these little plug-and-play devices, air filtration systems, the portable ones, well, they'll want to put a monitor right next to their device because it makes the most sense to detect the air as it's immediately coming out. And then you get the poor occupant who's sitting here with a consumer-grade monitor and it's reporting air quality that is terrible and is not reflective of what all of these other stakeholders are saying. So you have competing interests, and basically it's because everybody wants the monitors to be placed in areas that make them look good. So the Reset Air for commercial interiors and standards for core and shell were standardized means to codify and outline how monitors have to be installed in areas that represent the quality of the air being breathed by building occupants, the breathing zone. This is what we care about. For core and shell, it outlines requirements for the installation of monitors specifically in a way as to communicate the quality of the air being delivered by the building's mechanical system. So again, we want to make sure that if you're placing monitors in here, it's actually accounting for what your mechanical system is doing. And this is a careful means to make sure that we avoid what in the industry has been a lot of finger pointing, trying to figure out who is responsible for the delivery of the air and how do we actually measure it to see who needs to help with remediation or if the air quality is indeed as people say it is. So let's move to this next critical piece, which is looking at monitor standards, monitors themselves. Up until recently, we had only really two types of monitors. Those that were extremely high grade and they were fairly expensive devices, and those on the far extreme that were cheap consumer grade devices. And there's a real big difference between these two. For instance, this slide is showing grade A's on the left, and they're reading PM 2.5. You can see this one here is reading 53 micrograms. These are grade A. These are the high-end, well-qualified, reliable devices. And then you see a couple of grade Cs over here. This one's reading as low as 32. That's quite a difference in readings. And it's way too wide a gap when it comes to detection accuracy. And I think most people appreciate how different then these monitors can be both in reliability and accuracy, and how critical it is to have standards in place to create distinctions that can then report data on an equal playing field. And really, this is to safeguard against misreporting or misinterpreting data that we're using to evaluate our buildings. And a real-life example of this, this report was conducted in China in 2017, and it went viral throughout the country. The Chinese government bought a sampling of the most popular monitors off of Taobao, which is the Chinese equivalent of Amazon, and they tested them in a lab against a grade A reference monitor. And guess, of course, what happened. Of the 30 grade C monitors that they tested, all of them failed. Not one of them was reading accurately against a reference device. So I just want to point out, of course, that while this test was conducted in China, this is a systemic problem globally. It's an issue with grade C monitors, no matter where you are in the world. And most importantly, the lesson here is that old adage of buyer beware. A cheap consumer grade device is just simply not suitable for the type of robust information we need in order to gauge projects or to understand building safety and health. And then the last important thing to consider is the fact that all monitors will drift over time, all of them. So they must be maintained and cleaned, not just calibrated. Devices need to be taken through a comparative measuring exercise against a grade A reference device. In this illustration, the reference monitor is represented by this gray line. And you can see that the other monitors, in this case, they were all grade B monitors. They require calibrating. And this can be done in the device's software to match the reference grade. And the reset error standard requires accuracy within a range. And this is defined by your target. So even if you're not as accurate in the high sensitivity range, a monitor does need to be accurate in the target. So basically what this is spelling out is that reset includes a set of standards for 3 different types of monitors. And this is really important because only grades A and B are allowed on reset projects. So with respect to grade C, it's helpful to have this grade to describe for context, to provide information for comparative purposes. And this really helps weed out what we sort of call the toys, so to speak, so that consumers can better understand the difference between a gadget and a specialized piece of indoor air quality equipment. So the reset air standard for accredited monitors, as well as the accompanying test procedure for accredited monitors, has created an entirely new class of monitors for buildings. A few years ago, this grade B monitor didn't exist. And to date, there are a collection of manufacturers actively designing monitors in this space and using the reset air standard to qualify their devices in a transparent way. And so again, I've mentioned this before, but it's worth mentioning again that reset air is comprised of a series of standards that define a host of information. And this peer review for best-in-class providers and stakeholders to come in and chime in to make sure that these standards are written in the most robust way, again, helps us to codify and harmonize the industry when it comes to the assessment of indoor air quality. Said another way, reset is a standard for good data, a building block for everything else. And that brings me to the last important component of this section, which is the data, how to collect and report it. But honestly, this section is so important that it deserves its own section entitled Accredited Data Providers.